All right, good afternoon and welcome to Master Talker online class. In today's video, we'll be talking about general gas equation. But before that, let's talk about standard temperature and pressure, STP, standard. All right, first of all, uh, standard temperature. Standard temperature is simply temperature is 0 degrees Celsius or 273 Kelvin. All right, you need to know that the standard temperature is equal to temperature in 0 degrees Celsius or what? Or temperature in 273 Kelvin. But this is the one we normally use for calculation, 273 Kelvin. So this is STP. So anytime you hear STP, it means standard temperature and pressure. So standard temperature is this one, which means you use this one. Then standard pressure, standard pressure, standard pressure is something as 1 atm. 1 atm or 760 millimeter mercury. All right, and it's the same thing as what? 101325, right? 101325, yes, 101325 millimeter, uh newton per meter, square. All right, and don't forget that atm is the same thing as bar. So this is same thing as 1 bar. Millimeter mercury is the same thing as millimeter mercury is the same thing as Thor. It's same thing as Thor. So this is 760 Thor. Okay. While Newton per meter square is same thing as Pascal. So 101325 Pascal. Okay. So that is standard temperature and pressure. So anytime you hear standard temperature and pressure, you will use any of these. For temperature, it's just 0 degrees Celsius or 273 degree Kelvin. All right. So now let's talk about the ideal gas equation. I saw the general gas equation. The general gas equation is the relationship between volume, temperature, and pressure. Okay, and that is the combination of Boyle's and Charles' law. Don't forget that Boyle's law stated that the volume is inversely proportional to what? To pressure, and the same Boyle's law stated that what? That volume is directly proportional to temperature. So if you combine these two things, you have that volume is directly proportional to temperature and inversely proportional to pressure. Okay, so if you want to remove the proportionality sign to bring in the proportionality constant, you have that V is equal to what? KT over what? P. All right, so if you want to make K subject to formula, you know that K is equal to what? VP over T. So we now have that V1 P1 over T1 is equal to what? V2 P2 over what? T2. So this is the general gas equation. This is the general gas equation. So let's solve some calculations on that. Okay, don't forget that where V is volume, where V is equal to volume. All right, T is equal to temperature in Kelvin, YP is what? Pressure, and then my K is what? Proportionality constant. Proportionality constant. All right, so don't forget this your formula as we solve calculations. Now the first calculation we are going to solve said that okay, first of all, note that for the general gas equation to be used in solving arithmetics, the temperature must be in Kelvin. I said that. Okay, so in other words, if they give you temperature in degrees Celsius, you must change it to Kelvin. So the first question said 65 cm cube of dry gas, of dry hydrogen. All right, we are collected over mercury. Then I said the atmospheric pressure was 750 millimeter mercury. All right, and the room temperature was 27 degrees Celsius. Okay, then I say if the density of hydrogen of hydrogen is 0.09 gram per cm cube. All right, then they now say full stop. They now say what is the mass of the gas at STP. All right, don't forget the STP I told you before. So solution, the first thing we need to get is the volume, the V1. The V1 is equal to 65 cm cube. All right, so was collected over the pressure. The first pressure was 750 millimeter mercury. Okay, the next thing they gave us is the room temperature. T1 is equal to 27 degrees Celsius, which is what, 27 plus 273, so which will give you 27 plus 273 will give you 296 Kelvin. All right, now the next thing they gave us is what, the density. The density rho is equal to what, 0.09 gram per cm cube. All right, so now, but they said at STP, at standard temperature and pressure. So T2 is my standard temperature, which is what, 0 degrees Celsius, which is same as what, 273 Kelvin. So the next thing is what, standard pressure. My standard pressure P2, since this one is in millimeter mercury, so I'm going to use millimeter mercury, which is 760 millimeter mercury. All right, so I know my formula that say that V1 P1 over T1 is equal to V2 P2 over T2. So I'm looking for my V2, my second volume. So my second volume will now be, in fact, if I make volume subject of formula, this person will go up while this person will come down. So my V2 will now be V1 P1 T2 all over T1 P2. So if you put everybody now, you're having that volume 65 times P1 750 times T2. T2 is 273 all over T1 296 times P2. My P2 is 760. So if you do everything, you get that your V2 is equal to the second volume. The second volume will now be equal to 59.16 cm cube. All right, so but they're asking us the mass, but we know, please let me finish it here. We know that density is equal to what, mass over volume. So the density they gave us, so therefore my mass should be what, density times volume, which is what, the density is 0.09 times the volume, 59.16. So you will now get that the mass is now 5.32 gram. So that is that. Very simple question. So let's move to the second question. So for the second question, they said if nitrogen gas occupies a volume of 0.722 dm cube at 17 degrees Celsius and 0.42 times 10 raised to power 5 Newton per meter square, comma, then I say calculate the volume of nitrogen gas at STP. Right, the same STP again. So solution, the first volume they gave me V1 is equal to what? 0.722 dm cube. All right. Then the next thing they gave me is temperature. The temperature they gave me is 17 degrees Celsius, which is what? 17 plus 273, which is equal to um 17 plus 273, I think 280 is equal, okay, 290. So 290 Kelvin. So the next thing they gave me is pressure. P1 is what? 0.42 times 10 raised power what? 5 Newton per meter square. Okay. So now they say STP. So T2, which is the standard temperature, is 273 Kelvin. All right. Then the standard pressure P2 is equal to what? Since it's in millimeter mercury, is 101,325 Newton per meter square. Sorry, Newton per meter square. So I know my formula that said that what? V1 P1 over T1 is equal to what? V2 P2 over T2. So if I cross multiply, I'm looking for V2. My V2 will now be what? V1 P1 T2 all over T1 P2. So if you now put everybody now, you now have 0.722 times P1, 0.42 times 10 raised power 5 times T2. My T2 is 273. Everybody over my T1 is 290 times my P2 is 101,325. So if you do everything, if you press everything, you will have that the volume is 0.2817 dm cube. So this is very, very simple. Okay, so we move to the next question. We move to the next question. The next question, which is the last question I'm going to solve before we enter ideal gas equation. This one said, number 3 said, if both the volume and the pressure of a gas at minus 17 degrees Celsius we are doubled. Then I say calculate the temperature of the gas at its new volume and the pressure. Right? So very simple solution. They said that the volume V1 is the same thing as V1, but V2 is double of V1. Okay, the same thing here. P1 is P1, but P2 is double of P1. That's what they gave us. It is double. Then the temperature they gave us, T1, is minus 17 degrees Celsius, which is what? Minus 17 plus 273, which will give you that is 256 Kelvin. So I still know my formula. I'm looking for the new temperature. The new temperature is unknown. So for the new temperature, I know my formula that said that V1 P1 over P2, V1 P1 over T1 is equal to V2 P2 over T2. So I want to make T2 subject of the formula. So this one will go here, this one will go here, these two will come down. They will first of all swap. Why this one will go here? So T2 will now be V2 P2 T1 all over V1 P1. If you cross multiply and then make this subject of formula, you get this. So my T2 is equal to, put everybody, my V2 is 2V1. Okay, my P2 is 2P1 times my T1 is 256 divided by V1 P1. So V1 cancel V1, V2, P1 cancel P1. So my T2 will now be 2 times 2 times, that is 2 times 2 times 256. So I have, what do I have? 1024 Kelvin. As simple as that, right? So now let's move into the ideal gas equation. Ideal gas equation. Right? Ideal gas equation. Right? Ideal. Right? Now, for ideal gas equation discusses the relationship between the general gas equation and the number of mole, okay, and number of mole and molar mass, okay, and number of mole and molar mass constant, the number of mole and molar mass constant. All right. Now, in an ideal gas equation, we will see that the general gas equation, we said Vp over T, right, is directly proportional to the NR. Is directly proportional to the NR. So we will now have that if you remove this and put proportionality constant, you will now have that what Vp over T is equal to Vp over 2 is equal to what? KNR. Okay, so where we now have that okay, so if we now cross multiply, we will now have that what? But here my k is equal to 1. If my k is equal to 1, you will now have that Vp is equal to what? Vp over T is equal to NR. So we now have that Vp is equal to what? NRT. Very important formula to note, that Vp is equal to what? NRT. Please, very important formula to note. Vp is equal to NRT. Okay, so where my V is equal to volume, okay, my P is equal to what? Pressure, my T is equal to what? Temperature in Kelvin. All right, so my N, small n, is number of mole, okay, while my R is called the molar gas constant, okay. But sorry, this is how this is supposed to be. That Vp over T is equal to what? Is equal to N. Yes, is equal to N. So it's directly proportional to N. So therefore, Vp over T is equal to what? NR, where R is the proportionality constant there. Okay, so therefore my Vp is equal to what? NRT. This is my formula. I prefer this one like this. Yes, I prefer this like this. So we now have that your R is equal to what? The molar gas constant. The molar gas constant. All right, the molar gas constant. So and that molar gas constant is equal to, there's a way to find it. To find the molar gas constant, please, you should know that the molar gas constant R is equal to 0.082. Yes, 0.082 atm dm cube per mole per Kelvin. All right, so we can find that. How do we find that? You make R subject of formula to have that your R is equal to what? Vp over what? Nt. All right, at this point we are using standard temperature and pressure. So here we want to get the molar gas constant. Okay, the molar gas constant, the V is 1 dm cube, where my V is equal to 1 dm cube. Okay, then my pressure is in atm, so 1 atm. Okay, so my temperature is in Kelvin, which is 273 Kelvin. Then my mole should be in my mole is 1 mole. My N is equal to what? 1 mole. All right, so if you now put everything here, you will now see that your R is equal to what? If you put everything, you have 1 times 1 over 273 times 1, which is equal to what? 1 divided by the dm cube. Sorry, the standard volume. Do I call it the standard volume? The volume there should be in is 22.4 dm cube. Sorry, 22.4 dm cube. Yes, I forgot that. It's 22.4 dm cube. So I have 22.4 times 1 divided by this. So if you now press it, you are going to have this is equal to 0.082. Now, volume is in dm cube. We say dm cube. Okay, pressure is in atm. atm. Number of mole is in mole and it is down. You say per mole. Then temperature is in Kelvin and it is down per Kelvin. So that is the SI unit. So you need to know that the molar gas constant is 0.082. Okay, that is very, very important thing to note. All right, so write for me. Note, for ideal gas equation to be applied in calculation, pressure must be in the atmospheric pressure. It must be in atm, please. Very, very important statement. The pressure must be in atm, right? The pressure must be in atm. The volume must be in dm cube. Okay. The temperature must be in Kelvin and the number of mole must be in mole. In other words, if the data mentioned above are given in other units, they must be converted to the respective unit. So the first question here, okay, is the one I've already solved. We said, okay, look at that. They said, if the first question here said, if a gas of 1 mole at temperature of 273 Kelvin, volume of 22.4 dm cube, okay, and pressure of 1 atm, okay. They now said, calculate the molar constant. Calculate the molar constant. All right. So we know that for an ideal gas equation, we know that Vp is equal to what? nRT. Very important formula. So my R will now be what? Vp over what? Nt. So if you now put it, the volume there is what? 22.4 times the pressure is 1 divided by 1 mole times 273, which will give you what? 0.082. I told you is what? atm for pressure, dm cube for volume, per mole, then per Kelvin. All right, so that is that for that. So let's take another question. So we have gotten the value of the molar constant. The next question said, number 2 said, the volume of a gas is 20 dm cube at a pressure of 4 atm. All right, then I say calculate the temperature of the gas if the number of mole is 2 mole. Okay, solution, very simple. So what do we have? We have that what? That Vp is equal to what? nRT. Very important formula to note. So let us bring out all our parameters. The first one, they gave me that V is equal to what? 20 dm cube. Okay, they gave me pressure. Pressure is what? 4 atm. 4 atm. The next thing they gave me is my number of mole. My number of mole is 2 mole. Okay, the one they will not give you is R, is a constant, and you need to know it. That is what? 0.082 atm dm cube per mole per Kelvin. Okay, you need to know this value. Very, very important. So they are now asking me my temperature, which is unknown. So let me now put everybody. I know that my Vp is equal to nRT. All right, so we now have that. Put everybody. My T that I'm looking for will now be Vp all over nR, which is equal to what? 20 times 4 divided by what? 2 times 0.082. So if you do everybody, you will now get that the temperature is 487.8 Kelvin. 487.8 Kelvin. Very, very simple. So let's go to the next question. Question number 3. And question number 3 said calculate the volume calculate the volume of a gas at a pressure of 1000 millimeter mercury, all right, comma 400 degrees Celsius if the number of moles is 3 mole. All right. Okay. Solution. Let's bring out our parameters. The first thing they gave us is pressure, and they gave us pressure as what? 1000 millimeter mercury. All right. And I told you that your pressure must be in atm. So, but we know that 1 atm is equal to what? 760 millimeter mercury. So x atm that I'm looking for is equal to what? 1000 millimeter mercury. So if you cross multiply, you have that 760 times x is equal to 1000 times 1, which is 1000. So my x will now be 1000 divided by 760. To convert it to atm, you will now have 1.316 atm. All right. I've gotten my pressure in atm. So the next thing they gave me is temperature in degrees Celsius. My temperature is 400 degrees Celsius, which is same as what? 400 plus 273, which will give you 376 Kelvin. Okay. So the next thing they gave us is mole. The number of mole is 3 mole. Okay. They will not give you R, but you should know that your R is what? 0.082. So I know that my VP is equal to what? nRT. So what am I looking for? They say we should calculate the volume. So my volume will now be nRT over pressure. So what do I have? 3 times 0.082 times my temperature 673, now divided by my pressure 1.316. So if you do that, if you do everything there, you will now have that your answer is 125.8 dm cube. Okay, so that is that. The next question, question number 4. Question number 4. All right. Question number 4 said at a pressure of 2000 Newton per meter square, okay, they say the volume of a gas is 900 cm cube. Okay, then I say calculate the number of moles of the gas at a temperature of 50 Kelvin. At a temperature of 50 Kelvin. All right. Okay. Solution. Very simple. Now the first thing they gave us is they gave us pressure at 2000 Newton per meter square. But I know that 1 atm, it must be in atm. My 1 atm is equal to what? 101,325 Newton per meter square. So therefore, x in atm is equal to what? 2000 Newton per meter square. So therefore, cross multiply x times 101,325 is equal to 2000. So therefore, my x I'm looking for is what? 2000 divided by 101,325, which will give you what? Let's calculate that. Okay, 2000 divided by 101,325. So I'm having 0.0197 atm. All right. So the next thing they gave us is volume. They gave us volume as what? 900 cm cube. We need to make it to be in dm cube. I know that 1 dm cube is equal to 1000 cm cube. So x in dm cube is equal to what? 900 cm cube. So cross multiply to have that what? X times 1000 is equal to 900. So therefore, my x will now be 900 divided by 1000, which will give you 0.9. Yes, 0.9. That is 0.9 dm cube. So which other thing did they give us? Oh, they gave us temperature in Kelvin, 50 Kelvin. All right. So they didn't want to stress us there. Okay. So what do we do now? We know that our VP is equal to what? nRT. So what are they asking us? The number of mole, N. They're asking us the number of mole. So my N will now be what? VP over what? RT. Don't forget that your R is always the same thing. It doesn't change. My R is what? 0.082. So I will say that my V, what did I get as my volume? 0.9. So 0.9 times my temperature, my pressure, 0.0197 divided by 0.082 times the temperature in Kelvin is 50. So if you do everything, you will be getting 0.00432 mole. Okay, so that is that. Let me check my time. Okay, that is that. So all right, so let's solve more calculations on this. Okay, so the next thing we'll look at is formula for mass. Okay, formula for mass. How to get your mass formula for mass. Okay, we know that density is equal to what? Mass over what? Volume. Okay, so density rho is equal to mass m over volume. All right, so if you cross multiply, you will have that mass over volume. Okay, so now let's check the formula for volume. We have that PV is equal to what? nRT. So to get my volume will now be what? nRT over what? Pressure. So let us put it here. You will now have that what? My rho, my density is equal to what? This is m divided by volume. So divided by, what did I get my volume? My volume is nRT over pressure. So what do we have? We now have that what? My rho is equal to what? MP. If you turn it around, so or M times, it will now be P over what? nRT. So which is what? MP over what? nRT. All right, that is my density. So from here, we will now know that we want to make our N subject of the formula. Okay, so if you look at this now, you will see that this is mass over volume. Okay, this formula is very powerful. Please, you need to know that what? Density is equal to what? Mass over number of mole times PRT. This is a very powerful formula. But we know that the number of mole from here, we know that number of mole is equal to PV over what? RT. All right, number of mole is equal to PV over RT. But I know that number of mole is equal to mass over molar mass. Don't forget. So if you put it here now, you now have that mass over molar mass is equal to what? PV over what? RT. This is another formula you need to take note of. Very, very important formula. Okay, so that is that. Now, another thing you need to note is that Another thing you need to note is that density. Please note that density is inversely proportional to temperature. Very important. Please note that density is inversely proportional to temperature. If you look at this now, you see that density and temperature is down. So density is inversely proportional to temperature. So therefore, density is equal to constant temperature. So my constants are all these things. M, P, N, R are all my constants. So it will now be what? Is equal to density times temperature. So I have density 1, temperature 1 is equal to density 2, temperature 2. Another important formula to note. Another important formula to note. So we will solve calculations on that and then we are good to go. Okay? So let's just solve some problem involving all these things that we have written. Don't forget that your density is equal to mass times P over nRT. All right? Okay. So let us solve the first question. The first question here, number 1, said a sample of gas has a mass of 0.136 gram, comma, its volume is 0.112 dm cube. All right, at a temperature of 298 Kelvin. At a temperature of 298 Kelvin and a pressure of 1.06 atm. Then I say calculate the molar mass. Calculate the molar mass. Okay. Solution. Calculate the molar mass. Okay. We know that, let us get our parameters first. I know that mass is equal to 0.136 gram. Okay. And they gave us volume. Our volume is equal to what? 0.112 dm cube. Okay. They gave us temperature. Our temperature is equal to 298 Kelvin. Okay. Did they give us pressure? Yes, they gave us pressure. They gave us pressure as 1.06 atm. All right. So in the normal gas equation, what they did not give us is the number of mole. Let us find number of mole first and know what will happen if we can find the number of mole. All right. So I know that my PV is equal to nRT. So N that I'm looking for is PV over what? RT, which is equal to what? My P is 1.06 times my volume there is 0.112 divided by my R is always constant, which is 0.082. Don't forget, times the temperature there is 298 Kelvin. So if you do that, you are going to have let us calculate that. You're going to have 1.06 times 0.112, all right, divided by 0.082, okay, divided by 298. So I have that my number of mole is equal to 0.086, okay, mole. So but we know that the number of mole is equal to mass over molar mass. So molar mass that I'm looking for is mass over what? Number of mole. And my mass they gave me is what? 0.136 divided by 0.0048. So what do I have? So I will now have so if you do everything, you will have 0.136 divided by 0.0048. So I have 28.33 gram per mole. Okay, so that is that. 28 0.33 gram per mole. So let's solve more question. You see, these things are very, very simple, something to calculate. Number two question said calculate the mass of nitrogen. Calculate the mass of nitrogen 4 oxide. Okay, calculate the mass of nitrogen 4 oxide, that is NO2. I hope you know nitrogen 4 oxide gas that occupied 15.2 dm cube at 37 degrees Celsius and 830 millimeter mercury. All right, solution. Okay, first of all, let's get all our parameters. They gave me that that the volume V is equal to 15.2 dm cube, and they gave me that the temperature is 37 degrees Celsius, which is equal to what? 37 plus 273, which will give you 310 Kelvin, 310 Kelvin. Right? So the next thing they gave me is a millimeter mercury, which is pressure. Pressure is what? 830 millimeter mercury. So which is what? 830. Don't forget that millimeter mercury is 760 divided by 760, which will give you what? That is 1.092 ATM. It must be in ATM. All right. So what do we have next? We have our R, even without being given, 0.082. So let us still calculate the number of mole because it is not given. The number of mole is not given. So we now have that what? The same formula again, that our number of mole N PV is equal to what? nRT. So our N is equal to PV over what? RT, which is equal to what? My P is 1.092 times my V is 15.2 divided by my R 0.082 times my temperature. My temperature is 310. So what do I have? My N is equal to, so I have that 1.092 times 15.2. Okay, now divided by 0.082, then divided by 310. So I'm having that my N is 0.6530. Okay, mole. So they are asking us the mass, but we can calculate the molar mass. So first of all, we know that the molar mass of NO2, nitrogen 4 oxide, is equal to nitrogen plus 2 of oxygen, and nitrogen is 14 plus 2 of what? I think 16, right? Yeah. So what do we have? 14 plus 32, which is equal to 64 gram per mole, right? 64 gram per mole. So, but we know that mole N is equal to mass over molar mass. So mass that they are asking us will now be number of mole times molar mass, which is the number of mole here is 0.6530 times 46. So we now have times 46. So we're having 30.04 gram. Okay, that is 30 gram. So the next question, and okay, the next question we are going to solve said, all right, the next question said, it said the ring is not, okay, sorry, not the ring. They said 1.0 dm cube of trioxo nitrate 5 acid, all right, nitrate 5 acid, nitrate 5 acid is made by okay, by dissolving the gas NO2 in water. Okay, by dissolving this in water, then I say calculate the density of NO2 gas in gram per dm cube at 1.24 atm and 50 degrees Celsius. All right. Okay, so let us get our parameters, all our parameters. The first parameter they gave us is the volume. The volume is what? 1.0 dm cube. Okay, they gave us then they gave us pressure. Pressure they gave us is 1.24 atm. They gave us temperature. Temperature is 80 degrees Celsius, which is what? 80 plus 273, which is equal to 80 plus 273 will give us, okay, sorry, 50, not 8, 50. So I have 50, that is 50.273. So 50 plus that will give you 323 Kelvin. Okay, did they give us another thing? Okay, they did not give us another thing, but we know this our formula. We know our normal formula. Did they give us the number of mole? Did they give us the number of mole? Okay, they did not give us the number of mole. The number of mole is not given. Okay. Okay, but we know that this the number of mole is equal to what? What do I have? PV what? PV over what? RT. And I know that the number of mole is mass over what? Molar mass is equal to what? PV over what? RT. And they're asking us density. I know that if volume can come here, it will turn to density. So I know that mass over volume is equal to molar mass can come here. Pressure times molar mass all over what? RT. Mass over volume is density. So density is equal to what? Pressure times molar mass all over what? R times T. So what do I have? The pressure is what? 1.24 times the molar mass. They say the molar mass of what are we calculate? Calculate the density of nitrogen 2 oxide, and the molar mass of this we have gotten it before as 46, sorry. So that is the molar mass is nitrogen, that is 14 plus 2 of 16. So all over what? 0.082 times the temperature there is 323. So what do we have? 1.24 times 46 divided by 0.08 times 323. So if you do that now, you'll be having 2.1536 2.1536 gram per mole. Okay, so that is that for that. So let me check my time. All right, so I'm going to stop here. So you will now have to deal with the next question. So let me give you an assignment for you to work on. An assignment. Okay, you just tell me the answer on the comment section. Assignment said that what is the volume occupied by 35.5 gram of Cl gas that exerts a pressure of 1520 millimeter mercury, okay, at 50 degrees Celsius. right? So that is that. Calculate the volume. So thank you very much for watching. Please share, like, and subscribe. God bless you. In the next video, we'll talk about the next equation.